So today, what we're going to do, well, I'm going to help you, because we're going to get a data set that a client dumped at our doorstep, and they asked us to do something smart with it, do some prediction or something sexy, some machine learning. It doesn't really matter what, but it shouldn't be just somebody's shoe size or something. It should be something that I can make a little money with. And that's basically all the information that we got in this particular case. And of course, that's not what you would ideally have. And I will talk about that, because what we're going to do in this talk is we're going to go through the steps, through the process of what you're going to do in a typical data science project, at least where I came from. And at each of these steps, we'll see like what kind of input would we need actually from our client at this point. So it's a good case to flesh out exactly how you're going to approach a data science project. All right, so my name is Berendsen. I started with Luminis in September as a search and data engineer, doing all kinds of projects. For example, just application projects where we make web applications with Spring and with Angular, for example, on the front end. And we're doing data projects with Elasticsearch, but also with Python. So before I started at Luminis, I did a bachelor and master in artificial intelligence and a PhD in information retrieval. So when somebody looks at me with a bit empty eyes, I say, okay, Google, and but you know that stuff's been invented already, right? But yeah, that's what I did, and it's also known as search. It's really interesting. Today, the emphasis will be on the process of a data science project, as I told you, the choices that you will have to make at each step, and the kind of questions that you will encounter. And what we'll also do, so is step by step, step through the code, how do we do this? So this is going to be a talk for beginning data scientists who would like to do some data scientists. And on the other hand, it's a developer talk, so it tries to be two things. So really, walk through the code and actually show some code. So I hope I can accomplish all of that in just under 1 hour. So first, a little data science intro. It's going to be really naive. And then a quick look at the stack. Okay, so what kind of animal is this? Anybody's got any ideas?
A desert rat.
It's a rat. It's a kind of rat. It's a gerbil. So this question, that's a classification task. So given you've got some individual maybe, and you make some measurements, and you want to know what it is. So what category it belongs to. That's a classification task. Now a harder one, is this a male or a female? That's really hard with gerbils, even when you have them in your hands. And my sisters had 2 gerbils, and they started off, and they were told that were 2 males. And within a small period of time, and several generations, we had 24 gerbils. So suppose that I could measure the length and the weight of these gerbils. So now I'm just, so we call those features. I'm taking some measurements, so I'm defining some variables, some features, and I measure one of these gerbils. So now I have an observation. So now I want to know what is the gender of this gerbil. Right? So that's a classification task. Now if I had wanted to know what is the length of the tail of this gerbil, that's a different kind of task, because then I'm not looking for a category, but I'm looking for a number. I'm trying to estimate a number. That's a task that we call regression. But the focus today will be on classification. All right, so after I've measured one gerbil, I measure a couple of more gerbils, and then I call in the experts, not the guys from the store, and I ask them to determine for me, for these couple of gerbils, what their actual gender is. And then I will call these points my training set. For these gerbils, I know what their gender is. And now what I can do is I can take a machine learning algorithm. For example, I could take a linear machine learning algorithm. There are many of those. Support vector machines, for example. It's a sexy term. Now, what linear machine learning algorithms do is they can draw a line right through the middle of these points to separate the males from the females. So now in this case, I cannot do that perfectly, right? But an algorithm could still find a line that would kind of do that with the least number of misclassifications, as we call it. So for example, suppose that my machine learning algorithm found this line. So now it would say that on the right side of this line, if I encounter a gerbil with that kind of measurements, it would be a male, and on the left side, it would be a female. Then I would do some more measurements. And these measurements I will call the test set. And the test set, I will generate predictions for this test set, and then I can call in the experts again, and I can measure how well I predicted, right? On gerbils that I didn't see before. So this is basically all there's to it today. So that's all we're going to do. Classification. And if I have time, I can also do some regression. Okay, so now let's move from the gerbil to software. We're also going to do software today. And in particular, we're going to use parts of what some people call the Scipy Stack. So there's Scipy, scientific Python, and you have distributions, and then you can find all the Python libraries that you need for science in one place. Or you could install them separately. That's perfectly fine. So we'll start with Python. On top of Python, we'll use NumPy. So NumPy allows you to do calculations over a whole arrays of numbers or vectors or even matrices if you want. And on top of NumPy, we'll use pandas. Pandas will give us data frames. Data frames is a particular data structure that we'll see. It's also used in R, for example. R is another popular tool for doing data science. It's also available in Spark. And we'll use scikit-learn. And scikit-learn has machine learning algorithms. And all of this we will run in an environment, a shell, if you will, that is Jupyter Notebook. And Jupyter Notebook itself will run in your browser. So that's the stuff we use today. And this is how I installed it. So I installed a Python distribution. I used the Anaconda one, Python 3. And I got it here. And then with Conda, I installed pandas and also Jupyter, and the rest was already there. And if you get errors, there's Stack Overflow. Not me. Okay, so the process. Well, the steps that I'll be taking today are these steps. So the most important step is the business model if you're going to address a business problem. I'm not a financial analyst myself. But the business model, or more generally, the real-world process about which you're trying to predict something, that is the first thing that you should really try to understand. Because if you don't grasp that, you're going to go into the woods, or at least you're not getting out of it. So then we're going to clean the data a bit, explore it a little bit, and I'll explain what all that is, experimental setup. Feature engineering is the part where we design the measurements that we're going to take. So the measurements that we think will help us to predict whatever it is we want to predict. And then we fit the model like we just saw with the line. All right, so the business model. Understand it, like I said, what exactly do you want to predict? Do you want to predict, for example, what a customer will spend next year? Or do you want to predict which product he might click on if you show him several products on a website? There are all kinds of stuff that you can do here, and you have to be very, in the end, you have to make a very precise definition of what you want to predict together with your client. And how will he use these predictions? What decisions will he base on these predictions? This is important to know this because it will influence how you will do your predictions and evaluate your predictions. And what data does your client have to, what data to collect? What data should he maybe collect? Maybe you can advise him there. Now, none of this we did in this project. So we just said, okay, let's do the basic steps. Let's take a look at this data. And as a part of that process, we said, okay, based on this data, we might try to predict who will order again in the next period, given the data that we've seen. And we might even try to predict how much they will spend. Now, the second one, that's a number that we're estimating. And the first one is a classification task, right? Either somebody orders again next period or they don't. So that's two classes. So that's the classification task. That's what we're going to do today. So the first, let's say, hands-on step is the data cleaning step. With this kind of data, you'd be lucky because you could still see the basic idea. It's a house, a room, maybe. But there's some mess in there, maybe some malformatted data rows or columns. Maybe there's some duplicate stuff in there. Maybe there's some stuff that's wrong. We'll see some examples. But first, before we do that, let's say a few words about a data frame. So that's basically, it looks a lot like an Excel sheet. It's just tabular data. And we've got rows here. And on each row, we will get orders, because the data that we're going to look at is retail data. So we have an order, and maybe there's an email address associated with that order, maybe a time on which the order was placed, maybe what the customer paid, or maybe what he got refunded later. So this is what it's going to look like. So now I'm going to switch and show you some Jupyter. Now, how many of you have ever worked with Jupyter before? Okay, not too many, so I definitely need to introduce that. Python? Okay, most of you, but not everybody. So I'll show a little bit of Python. And I'll try to be fast because time is limited. And we want to do some prediction in the end. Okay, so this is a Jupyter Notebook. And I will mirror my displays in a moment. This is a Jupyter Notebook, again. Can everybody read this? Okay, so we have here, this is just a web browser that I opened, right? Did I maximize it already? Yes, I did. So it's a web browser. And I loaded a page from my local host. So I'm talking to my own computer. And this is a bunch of controls here on the top, and then I get cells, and that's what I get. This is a Markdown cell. If I double-click it, I can edit it, so I can put my documentation here, and I can execute it by hitting Shift-Enter. So now I do some Python here. In Python, you can say A is 1, E equals 1, and now I can print A, and now I can increment A. Now if I execute the cell above, who thinks that the value will be 1? Nobody, because it will be 2. So this is how it works. So the variable A lives in this kernel, and it gets incremented. And if you go back and you re-execute cells, you're screwed. So what you can do, and once you did that, you can say, okay, I'm going to restart the kernel, so the interpreter, clear all outputs and restart it. So now it's forgotten all about the value A. So if I print it now, it will say it's not defined. So that's basically the idea. That's how it works. So now I'm going to discuss Python. So the first thing is lists. So in Python you have lists. So let me just start by running everything above this cell. So we can define a list like this and print it. This is what it contains. I can assign to an entry of it, right, like that. One of the nice things about Python is I can slice. So what I just did here is I took everything from after the first entry in the list until just until the last one, like just before it. So it just contains one entry. I can modify that entry, and lo and behold, my original list is unchanged because slicing made a copy. And what I just did here with slicing is I iterated through the list with a step size of -1, which means I started actually at the back and I walked back, so that's useful. I did use that in an earlier version of my data science project, but I don't anymore. Then we have tuples. They're also lists, but they're immutable. So I can't assign any value. And then we have dictionaries. I'll use those in my code a lot. So dictionaries are just hash tables. The syntax looks like this. So I'm now assigning a value of 1 to a key A. I can access it. My tuple that I had just defined is not in there. But I can assign it, and now it's in there. So what's interesting to note here is that I can use tuples as keys in a dictionary, and that's very useful. With data structures like this, I find that I never need to use objects or classes. I don't know who shares that experience with me, but let's continue. So you won't see any Python classes today. Now NumPy, not the newest version. In NumPy, I can create arrays. So here I am turning my list, L, into an array, and I'm assigning that array to two variables, x and y. And now I can add them together, and what it did entry-wise addition. So it did 1 plus 1, 2 plus 2, 3 plus 3, and this is called a vectorized addition operation, and it's much faster than using for loops in Python. So you'll see me using that a lot in the upcoming minutes. And also here you can do slicing. I'm gonna skip past that. And you can also, the difference is if you slice in NumPy, it's fast. It doesn't create a copy. So if you do assignments, be careful. I can do another kind of indexing, or advanced, or slicing. They call it, it's one kind of advanced indexing. So this is interesting. If I run everything above, there will be cells that I executed twice. So maybe stuff will break now. But anyway, here we are. So here I append not a number. Look, there's 2 now. And here I say, okay, give me everything of this array x that's not a number. What this will give me is a Boolean array, like you just saw above. Now I can negate that array, and that will give me true, 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 false, false. And then I can index x with that, and that will give me all the numbers. And this one will, again, create a copy, so the original one will not be modified. Now in NumPy you get all kinds of stuff that's useful, for example, means, standard deviations, all kinds of computations that you can make over whole arrays or matrices. Okay, so now a brief introduction to pandas. Pandas gives me data frames. So I can, for example, create a data frame like this using a dictionary, as you see. So I'm now creating a column A, and I'm putting in the values 0 and 1, and a column B, in which I put the values 2 and 3 in. This is what it will look like. And as you see, it has added an index by itself, 0, 1. So this is my index, my rows, and these are my columns. And there's another data structure that I'll be using. It's a series. And here I have a series is just an array, so it contains 5, 4, and I'm giving it manually an index, 1, 0. Okay, so this is what S looks like. So there you have the index on the left. Now, and I can assign this series to my data frame like this. And now I have 3 columns. And look what it did. It swapped the 4 and the 5. So it aligned the series with the index of the data frame. So it does some bookkeeping for you, but you have to be aware of what it does. Now, and I can index this data frame with all kinds of in all kinds of ways. I can select a column. I can do the Boolean indexing. So now I'm selecting odd numbers from column B. Don't worry if you missed that. I can do label-based indexing. So I use the labels of the index. So I'm selecting the first row, the column B. So this is not the first row, actually. This is the row with the label 0. And here I'm selecting all rows, and I'm selecting columns B and A, and I'm swapping them. And this is the result. So, useful stuff. Also, I can use integer-based indexing. So now I'm using familiar slicing techniques, right? But I'm just using the numbers of the columns. So what I did here is I used a step size of 2. So that got me the first and the third column. And I selected all rows. Now in pandas, as in NumPy, sometimes when you do slicing you get a view, sometimes a copy. Okay, so just be careful when you do assignments, that's all. Right. So the first actual data science step. I'm importing pandas, just setting a variable here. Better. And now I'm just reading a CSV file. And now we get to the high-level stuff that's useful. What's useful about data frames is you can do a lot of stuff with a little code. So let me just see what's in this data frame. I just select the top 5 rows like this. So I got my index here on the left. And I've got my columns here. I've got an email address apparently, which is anonymized. And I've got a timestamp. Got a total paid, total refunded, total cancelled. Now you see these NENs here, not the numbers. And I've got whatever was ordered. Then I've got this weird column here. Now I can say describe this data frame for me. So now what I get is some summaries for all the numeric columns in my data frame. So you have your count. You see the counts differ, because this is the count of the number of rows in which this column had a number. You've got your mean, standard deviation, minus, your maximum. So really useful. Now one of the things when you do data cleaning is you're going to check the correlations between all your variables. And again, you can do that using this very simple command, df.core. Alright, so what this will give you is correlation between all your numeric variables, right? So on the diagonal, we'll get ones. Variables should correlate perfectly with themselves. But there's this one here, and this is the kind of thing you're looking out for in the data cleaning phase. So we got base total paid that correlates perfectly with total paid. Now in the real data set, I had, I think, some 30 columns that I had to remove because of this. So if you look closer into it, it turns out it's an exact duplicate. So let's drop it. So I'm just dropping this column, base total paid, on my data frame df. Very simple. X is 1. That means I want to drop a column rather than a row. And let's check the correlations again. And I got rid of this duplicate column. And I've also got these not a numbers here. Now that actually makes sense because it never happens that an order is refunded but also cancelled. That would be really nice for a customer. Okay, so another thing that is going to be wrong in your data, and it was wrong in our data, is, I don't know if you saw this before. If you did, then you were really fast. The maximum here looks like an order of 100 bigger than the maximum in either of the other columns, which again is too good to be true for our customer. And so we actually need to manually check if the units that are used for numerical columns are the same. So let's divide that column by 100, and I really had to do this. Again, so describe, and now everything looks more normal. So that's the kind of stuff you do when you data clean. You just check that everything makes sense. And here I'm going to serialize. So I'm going to save the cleaned dataset for later use. All right, let's close this thing. And go back here. So in the next phase, we're going to do some exploration. I'm not going to stand up for this one because it's really short. So in exploration, you've got some idea. right? You read a book maybe on Wall Street, and you think you know something about economy or about business, and you've got some hypothesis maybe, and so you go into the data again and you make some plots, and you see if your idea checks out, right? So you take your coffee and you go into your data. So thinking about our data once more, it's orders. So there's time and orders come in. Orders got a customer associated with them, right? So who knows any of these customers? Good. This is really, really important part of anybody's upbringing. So all of these customers are actually from the same company. So we should define at some point, or we should ask our client, what do you think of as a customer? Is that a company or is that an individual? Now, I have no idea about my retail data. I didn't talk to a client who knows something about this business. I don't know where this data is from, so I'm going to make a choice later on. Okay, so and what we have in our data is 1 year. Okay. Again, some Jupyter. So now I'm going to do some exploration. Now that looks manageable. Nothing too scary here. I'm just saying with a bit of magic that I want plots to show up actually. I'm reading in my data again. And this bit I didn't show you. I want to check what types pandas thinks it got. And what I'm seeing is I'm seeing two types. I'm seeing that the created at column, it thinks it's an object. Well, an object is not an object in an object-oriented programming sense. In pandas, this just means it couldn't parse it as a number. Then I've got a couple of floats, and I've got another object. Now, what I actually want to do here is I want to make sure that this created at thing, that Panda understands it as a timestamp. So that's what this function does. And I'm assigning that. So now when I do this, I get datetime there. So that looks good. Because I'm interested in how my data changes over time. So what I'm going to do is I'm going to set the index of my data frame. Instead of these stupid numbers, I'm going to say I want the timestamps there. So that's what I do here. And then if I want my plots to be to show correctly, then I need to be sure that these timestamps are actually sorted and they actually weren't sorted, like you would expect. So I'm sorting them explicitly. And now, again, why is it so useful to use a data science software package to do data science? You got these high-level functions. So now I've got this time series data frame. Because I've got so this df now it's got an index made of timestamps and they're sorted. So I can think of this data frame as time series data. So now I can just resample that. Resample on a daily basis, which means I'm going to downsample. So I'm now going to aggregate actually for each day all the orders that I got. And the aggregation method that I want to use is I just want to count them. So how many orders do I get each day? That's what this statement does for me. And if I now look at my data frame, I got all these counts in here. So really useful. And I'm taking one of these columns and I can plot it like this. And I just get a plot in my notebook. And if I send this to my client, he will have the same plots. He can re-execute the notebook. And whenever you make a plot like this, you maybe answer some questions, but you will always get more new questions out of it. So you go back to your client and ask him, like, why the hell are there no orders in most of February and in March? That looks like some kind of error. Maybe the system was down, or maybe there's a real reason for it that I would really want to know. And why are all these peaks here? Maybe there seems to be some kind of regularity in these peaks. Can I explain that, actually? So I'm getting all these questions. And look at this one. Now, this one's actually easy to explain. Why is this peak so high? Does anybody have any idea? Yes, it's Christmas. Yeah. So that's it. That's all I'm going to show about exploration. So I've got unsaved changes. I don't want complaints. Right. Okay, so the next step is experimental setup. So, and I'm going to explain to you guys what this is, and or actually I'm going to show an example experimental setup, and after that you will understand why this is actually important. So again, this takes a little bit longer, so, and I need some break. So, all right, so we want to predict something about some point in the future. So we're going to make a choice for a particular period in the future. We're going to make some predictions. And we're going to go back to our client and ask him, like, how long in advance do you need to know this? And he might say, well, I need to know this a week in advance so I can do something about it. I can call this client. Remember that we want to predict if a client comes back or not, right? So we have an action period. And now we could go and we could take all our data and we could train a prediction model, perhaps, and then unleash it on the world. But before we do that, we want to have some kind of idea, like, is this any good? So that's why we're going to do an experiment. And for this experiment, we're going to pretend like we didn't know what happened in the particular period in the past, like here, this historical prediction period. So we're going to predict stuff for this period. And we're going to do that for some data. One more important detail is that the data that I will be using to make this prediction will be the data before this action period here. So this data I will use because I need this action period here as well, so I'm going to use it here as well. Okay, so now in comes some data. Now these bits shouldn't be there because we don't know if they'll be there. But these ones we know, and we'll try to predict these ones. So for example, for Jannie, we'll have to predict that she did in fact come back. Now Guus did not come back. Pruimpit did come back. Okay, and we're going to use the data in this period to make some measurements. We'll make some features out of that. And then we'll fit a model that will correctly, or as correctly as possible, predict these points. Now to evaluate the quality of that model, so okay, we'll call these customers our training set. To evaluate the quality, we'll take some new customers. We'll calculate the same features as we did here for these ones, and we'll try to predict these labels. And because we know them, we can see how well we did. This is what our experiment will look like. And in our code, we call this period spring and this period fall. And when we evaluate how well did we predict, we might think of several things, like how many customers that came back did we predict correctly? How many that left did we predict correctly? And we can ask our customer, like, which one do you think is actually more important? So, and that might influence which model we pick. And if we want to do regression, well, how close was our prediction of what they would spend? So after this phase, we will end up with a data frame that looks a little bit like this. So we grouped our data now by customer. So each customer had its own data, as we saw in the previous slides. So on the rows, we'll get customers. And we will get, here, this is a column that will contain what we want to predict. Did this customer return in the historical prediction period or not? And what did he spend there? And these columns we will look at now. So these will contain features or independent variables, as they are sometimes also called. All right. So the next step, and I will show these two steps in code, one after the other, because they're intertwined in my code. This step is feature engineering. So I use a picture of a drone here, because ideally I'd like to read the mind of my customer. And even then it might be hard to predict whether or not he would come back, because I don't know always what I will do myself. But since I can't read my customer's mind, I might want to install cameras in his living room. When he's behind his computer, I'd like to follow him online. And maybe then I could predict something about, will he come back to me? Like if he was looking at Google and he was searching for competitors of mine, maybe he would not come back. If I had that data, I could make a useful prediction, but I will not get that data. So what data can I collect? Well, I can collect everything that my customer does when he interacts with me, and that's the least I should do, and you should be very careful about that. And if I do all of that, then maybe I will be able to do some prediction. So I'm going to go through this really quickly. So when a customer comes in, he starts a customer journey together with you. Yeah, the customer relationship starts. Okay, and maybe you know something about this customer that comes flying in. Maybe he has an age, an education, hobbies, I don't know. And then he comes into first contact with you. And now you want to register, like, how did he come in? Like, what channels is he sensitive for? Like, does he like to go to physical stores? Did he come in like that? Or did he come in a website? Did I send a mail campaign? Then he suddenly responded out of 1 million people. Maybe I called him. Or you saw a billboard, Google Ads. So you want to keep track of all this. Now, not all my slides are going to be this pretty. So once the customer gets in, like he buys some of your products maybe. So, well, what did he buy? How many? How much did he spend for each order? How much time was there between his orders? Did he pay his bills? Well, anything you can think of, basically. Did he have complaints about my product? Is he happy? Like, I want to predict if he's going to return. So, if he's not happy, he's probably not going to return. So that I should keep track of everything, like reviews online, social media maybe. We'll get to that, I guess. Did he opt in of my newsletter or did he opt out? Did he share something on social media? Did he maybe bring in another customer? Or what do my customers typically do before they end customer relationships? All of these things. Now, let's look at our modest data set where we just have this order data, right? What kind of features might we get out of that? Okay, so this one, a little bigger. Just a little. I might not have time to explain all the steps, but I'll do my best. You've seen this before, the head, you've seen that before. Let's take a quick look. I've got my created at timestamp here. So that's what I'm using to index now. I've got my email address. I've got my data. Looks good. Okay, that's what you should always do. Shape. How many customers are in there actually? Oh, about 15,000. That's not really big data. That's good, because otherwise we'd be here for a while. Although you can connect with a Jupyter Notebook like this to a cluster of computers that's working for you. This is just a helper variable. I'm just adding a column, revenue, like I would do in an Excel sheet if I want to calculate something. I'm using this fill NA bit here, which just means that at this point, if something has no total paid value, then I will just say it was 0. And that way, my calculation will not contain any not-end numbers anymore. So now I'm going to make this split, if you remember, between this training period and this historical prediction period. And our code is really simple. I'm not going to have an action period. It's going to be 0. I'm just going to say anything before the 1st of July I'm going to use to train, and I'm going to predict whatever was after the 1st of July. Now that's not ideal, because I'm missing seasonal trends. Like the Christmas break is going to be in my prediction period, but it wasn't there in my original period, but all I've got is 1 year. All right, so what I'm doing here is I'm using indexing, as you saw, to make 2 data frames. One that will contain all the orders of the spring, and one that will contain all the orders of the fall. And then I will group by customer, and that's only this statement. It doesn't really do anything yet. It just tells, it just gives me back a group by object that I can subsequently use to go over each customer, and then I will get a data frame that will contain only his or her orders. Now I have to do the same thing. For the fall orders. Only this step here, I just filter out all the orders by people that I'd never seen in the spring, because I'm not going to predict anything about those people. All right, so I'm also going to group my orders that I got in the fall. So now, in my experimental setup, which I'm doing, I want to pinpoint what exactly is it that I want to predict. I had this total paid, total cancelled, total refund. So I figured out that I want to predict revenue. I already got this column. I added it before. So, and another thing I wanted to predict, and that's actually the main thing today, is whether or not the customer came back. So whether or not he has an order. Now this statement looks a little bit imposing. So I'm taking the fall orders here. And that's actually so by email. So that's the group by object for the fall orders. And I'm going to aggregate. So I'm going to take this data frame for each customer and I'm going to reduce it to a single number for each column. And I can here, this is a dictionary that I'm putting in. And I can say which column, like for each column I can do a different aggregation. So for the column products ordered that I had, which is just a hash, which is always there. If there's an order, this column is there. So for every order, so I'm going to do the following aggregation, namely this one. I'm going to say, does this customer have an order? I'm going to say, yes, he does. Because, this is the fall order data frame. So every customer that's in here has an order. So I could have done this an easier way, but I wanted to explain this aggregate stuff. Now revenue, I'm going to take I'm going to take the revenue column and I'm going to create an aggregation that I'm going to call predict revenue, and that's going to contain the sum of everything that he or she ordered in the fall. So if you notice, to this aggregate function in the end, I can pass functions. So this is a function actually in Python, an anonymous function that takes so it takes an array. So the products ordered array, and it returns you can define an expression here, and that will be returned. So I return 1, but you can also pass a string. It will recognize some strings, so sum, then it will apply a sum method. All right, so, whoops, I have to do it. Okay, so now the result is this. I've got 990 customers that came back. They have an order, and this is this is the revenue that they had in the fall. Now this is nasty. I have to index each column using a combination of 2. That has to do with how it came out of this aggregate function. So I'm going to do some ugly, create a new data frame, and this is what I'm going to use. So. Okay. This one is a little bit more imposing. All right, but it's a nice one. So it does a lot of work, this one. So again, I'm aggregating, and for each column in my raw data, so for example, for products ordered, I'm creating aggregations. So what I'm doing now is I've fixed my experiments, right? I've got my training set, I've got my test set, I know what I want to predict, so I've fixed everything. Now I'm actually going to compute some features. So I'm using the Spring orders, and for each customer I want to create some features. So based on products ordered, I just want to know, well, how many orders did this customer make? That's what count does. How many unique orders? Like, does he buy the same thing every time, or does he buy different products? Does he have a diverse taste? On how many days did he order everything? Like, did he make several orders in one day, or did he actually go to bed, sleep, and remember me on another day? Like, did he really? So that would be even better. Now, of course, I can do that really concise here. So again, this trick, I'm just resampling this time series of the orders for this customer on a daily basis, and I count how many there were on a particular day. So I get a new time series. I'm just going to count the number of days for which I have a non-zero amount of orders. Now, total refunded, these ones, they're simpler. Another one that's maybe a little bit more interesting is average time between orders. I'm not going to use a for loop here, but I'm going to use a vector calculation. So to make it a little bit faster. Okay. Okay, so let's do it. And this is what my data looks like. All right, so now I've got something, I've got a smaller data frame actually, that's just containing rows, one row for each customer. And that looks really manageable already. Okay, so now I'm going to add another column to this data set. And that column is going to indicate whether or not I want to use this customer as part of a training set or as a test set. So there we go. I'm going to just generate some random numbers with this statement. So because I use the same seed, it will give me a fixed series of random, pseudo-random numbers. The same random numbers every time I execute this notebook. And I'm going to say, in this column, I'm going to say that if this random number for a customer is lower than 0.7, I'm going to say he's in a training set, and otherwise he's not. And now I'm going to take these raw counts like that I computed out of this aggregation, and I'm going to make some actual features. So I'm saying, for example, I'm not interested in the exact amount of orders that a customer made. I just want to know, did he make more than one order? This is just an opinion. I just think that that distinction matters more than the precise count. For example, is it 2 or 3 orders? And so I'm just defining a couple of features again. With vector calculations. So this is a trick that I use a lot. So I make a Boolean array here. I'm going to say if a particular column is bigger than 1, then it's going to be true, and otherwise it's going to be false. And then I'm going to say, but I want this column to be of the type integer, so I get either 1 or 0. So now I have computed, if I actually executed this statement, I have actually computed all my features. There's one more thing I'd like to point out here, is that I've got my training set and my test set customers in here. Now that doesn't really matter until I start to use more than one customer in my calculations. And I have this one feature here, is last order long ago. And I'm going to use the average time between orders of all my visitors that I had calculated before. And I'm going to use the time since the last order of my current customer. And if it's longer ago than the average time between orders of all customers, I'm going to say this order is long ago. Now, but when I calculate the average time between orders, I shouldn't actually use all customers. It's important that I only use customers that are actually in my training set. So I do that with this selection here. So that's just the tiny bits that you should take great care with when you do data science. Right, so let's do that. And then this is what my features look like. And now I've got actual features. Did he cancel an order? Or she? Does he or she have more than one order on more than one day? Were these orders diverse? Was there a refund? Is the order long ago? What's the average that somebody spent? Now the rest is just some bookkeeping. So I'm going to add in the variables that I wanted to predict in my data frame. And for customers that I don't have in this fall data set, I'm going to put 0. So those customers did not come back, and they ordered 0 for a 0 amount. And then my final data frame will look like this. So now I have these prediction values in there. So this customer did come back. This one didn't. All right, so now that I have all of this data, I can already start taking a look at the correlation between my input variables and what I want to predict. And for that, again, I use only customers in my training set. I don't want to look at customers in my test set because I couldn't look at future data either, like in the real world. And I want to know that I'm able to predict test set customers that I've never seen before. So let's look at that correlation. So, what do we see? Now, we see that data is not actually easy. And I predicted that it wouldn't be easy to predict real customer behavior on the basis of such little data. But there is some correlation. Has order on more than one day has a positive correlation, albeit small, with predict has order. So that's now there's a start, at least. Okay, so that's that. Let's serialize the training set and the test set, and we're done. And we're ready for the final phase, which is model fitting. Now I'm going to go through this quickly. So in model fitting, we selected a machine learning algorithm, and then we'll just turn its knobs until the output sounds right. That's the analogy here. So one example is a decision tree, and that's what I'm going to use. Now suppose we have this recency kind of feature. So was this last order long ago? And we have the average revenue per order. And so we've got some observations. So each point here is a customer, and the plus is that means the customer comes back. And a minus means he's not gonna come back. Now decision tree will try for both features actually. It will try to find a threshold value. For example, here it picked the recency feature, and it selected the threshold value somewhere in the middle. It will select this value such that it splits all the data points such that the pluses and the minuses are best separated. So at each side we'll either have only pluses ideally or only minuses. Now we didn't quite manage that, but we got a quite good split. That's what a decision tree does. That's all it does. And I could stop here. But if I wanted, I could allow it to continue, and it would just do the exact same thing on either of these halves. So for example, here on the bottom half, it picked average revenue per order and made another split. And on the top half, it picked recency again to make a split, and it made another split. Now, who of you thinks, that's actually, allow me one quiz question again. Who of you thinks that I should continue with this until I've got perfect score? Like what I would predict in this area, for example, I would say whatever customer I find here is a minus, and here I would say it's a plus because that's the majority. But if I would continue, I could like box in this one here, for example, and then I would get perfect score on my training points. Who thinks that's a good idea? It's not a trick question, not really. Okay, you're all advanced data scientists. Because if I do that, that's called overfitting. So I won't do that, because I might, for example, end up saying that this is a minus also, whereas it might actually be a plus. Congratulations. So I'm going to use the last couple of minutes to show you what this looks like in code. And with scikit-learn, that's actually a breeze. So this one's going to be really small again. Let me mirror. All right. So, you've seen this. This is my scikit-learn version. I'm going to read in the data. I'm going to generate some random numbers again. I'm using the same seed, but it wouldn't matter. And then I'm just going to instantiate a decision tree classifier in this statement. Let's do it. And what I'm telling it is that I'm saying you can continue for a maximum of 3 steps. Not too deep. I just want to get the first idea. And in every corner of, like in every box, you have to keep at least 5 data points. So that's another measure to prevent this overfitting. Then, okay, there's a lot more people that actually go away, but I don't want you to favor them. So I want you to take into account class imbalance. That's what that's called. So that's what I do here. So you have to know a little bit, like what are the knobs and whistles of each machine learning algorithm. You have to understand a little bit about how they work. And I'm passing in this random state so that I don't get embarrassed when I do this demo again and something completely different comes out. I did that. Actually, now I did it twice, and now I'm screwed. So because this statement has side effects. Okay, so I'll just run everything above this once. I think it's done. So now run it once. So okay, this is in my training set. This is the columns. This is what it looks like. Everything looks good. And now I'm going to select everything from this with the integer indexing right, except the last two columns. I don't want those. So now I've got just my features, not the variables that I want to predict. And now I'm just going to predict the variable. Going to select the variable that I want to predict. Does this customer come back or not? So, and then I just put these features. Oh, wait a minute. There's dot values here. That makes, so before this part, it's just a pandas data frame, right? But here, when I do dot values, it's going to give me back a NumPy matrix, you could say, a two-dimensional NumPy array. So I don't think I needed to have done that, but I did it. And that's actually what this scikit-learn classifier, this tree classifier, so CLF, is going to take as input. And I just tell it to fit a decision tree such that for these input variables, I can, as correctly as possible, predict these output variables. So fit it. And then all I have to do is for the test set, from the test set, I also select all the input variables here. And the output variables, what I want to predict. I do that separately. That's just the way scikit-learn likes to have them. So there's nothing special. And now I tell my classifier to predict labels, which are often called Y, output variables often called Y, for this input variables. So that's that. And now let's see how well did I do. So that's a classification report. So out of so these are the customers that actually went away. That's class 0. They never came back. Out of the 100 that never came back, this recall means I guessed 48 of them correctly. That's a big achievement. So I'm really happy about that, but maybe my customer didn't care about that. I don't know. But of all the customers that I said were going to leave, 81 actually left. And this class, I'm not sure about that. I feel a little bit less comfortable there. So out of all the customers that stayed, I was able to predict that correctly for 33. And out of everything of whom I said stayed, only 39 actually stayed. So what does my customer think is more important? Like what will this cost him? Or what will the missed opportunity be? So with that, I'm going to leave you. I think I have one more slide. Takeaway points. Understand your business model. Be careful when you set up an experiment to do prediction. You should really put some thinking as well. And other than that, I've just showed you interactive data science, which I thought was fun. And I think it's a productive way of doing data science. That's it. Any questions?
How long did it take you to set this up? Because I assume you showed the data set. I mean, now you go through it in less than an hour. But how long in a real world does it take you to do this?
I think on this data set, I spent 2 weeks. Yeah. And then I spent another week to prepare the slides. And then I did a demo presentation, and of course my code was completely not suitable for demoing. So this is not the first version of the code. I then spent another 4 days to make the code actually readable and demoable and fine tune the slides. So, but the project, I would say, was 2 weeks. But of course, this is only it's a very naive setup. I mean, in a real project, you would have to put a little bit more thinking in what you're gonna predict. What data do you need for that? Because this is just a bare bones, like an educational data science project to show the steps. Yeah. So I had to remind you, was told to remind you to use the cards. You know how to use them by now, so. Okay. Thanks a lot.